All right, so we're going to start off with classifying numbers. So what's important with this chart is that it goes from the bottom to the top. So it starts at natural numbers here, and then it goes to whole numbers, and then integers, then rational, then real. And we see these plus here because whole numbers are natural plus this. Integers are whole numbers plus this. Does that make sense? So those things are added together. So let's dive in and really focus on the bottom first, and then we'll scroll to the next one. All right, so let's start with natural numbers. Natural numbers are numbers you can count with your fingers. So numbers you can count with your fingers. So what I mean by that is when you start counting with your fingers, you go 1, 2, 3, 4, 5, blah, 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 right? Do you ever really put 0 on your fingers? Well, I know you're thinking, I could just hold up no fingers with like an O, right? But that's not really 0 fingers. You're just, it's weird, but 0 isn't included in natural numbers. Can I do negative numbers on my fingers? Technically, I could count -1, but I'd still be putting up 1 finger, 2 finger, if that makes sense. So it's just positive whole numbers. What about 400? Could I count to 400 on my fingers? What about 10,000? Yeah, if I really wanted to, I could count that high, but I wouldn't on my fingers. But those are still natural numbers. So examples are natural numbers are numbers like 4, numbers like 10, 300, 4,000. If you think of any, you can certainly add them there. Okay. So let's jump to whole numbers. Whole numbers are natural numbers plus 0. So that's the only difference. There's natural numbers plus 0. So whole is natural. So natural numbers plus 0. So we have the same kind of numbers. So I would put the same ones we did before, but now we have 0 included. So maybe 0, 25, 4, 67, 7,231. So just random numbers. Those are whole numbers. So it's natural numbers, things you can count on your finger, plus 0. All right. Let's scroll up a little bit to integers. Integers are whole numbers plus negative numbers. So let's remind ourselves what negative numbers are. Negative numbers are things like -10, -6. Remember with negative numbers, you kind of count backwards, right? Well, not backwards, but the way you order them is backwards, really. Because the bigger the negative number, the smaller it actually is. Do you think we should include 0? Yes, right? We should include 0 because 0 is a whole number. What about 74? Should we include 74? Yeah, because it's a whole number. So integers are whole numbers plus negatives. And I'll just be putting the examples in these side arrows now. So all the examples instead of at the bottom are just going to be in the side arrow because now I have more room. All right, so let's look at the next one. rational numbers. Rational numbers are integers plus fractions and decimals. Okay, so integers are all fractions. Sorry, not integers. Rational are all fractions are rational. All fractions. Certain decimals are. The decimals are terminating and repeating decimals. So decimals, repeating and terminating, repeating and terminating decimals, plus integers. Which, remember, integers include whole numbers and natural numbers as well. So it's just like a step ladder up to rational numbers. So all fractions are in there. So any fraction you can think of, a positive fraction, a negative fraction. But let's look at decimals. You may be thinking, what does terminating mean? Terminating means it ends. So an example could be like 1.5. That ends. That stops after 0.5. Or something like 2.0. 2.0 is the same as 2, so it's an ending decimal, it terminates. Or even something like 7.23456. It ends at 6, so it doesn't keep on going, so it stops. Repeating decimals are ones that repeat. So think about the fraction 1/3. 1/3, if you put it in your calculator, will give you 0.33333333. It never ends. It's a repeating decimal. It never ends. And the same number repeats constantly, or the same numbers repeat constantly. We mark that as generally, don't remember if maybe you remember, we mark it as whatever numbers are repeating, we put a repeating bar over top. So we'd put that repeating bar, which tells you that this 5 would really be 5, 5, 5, 5, 5, 5, right? Okay. Another thing that sometimes on test or study island and stuff, they're going to try to trip you up because you'll see a long number that it doesn't look like the numbers repeat, but it's that a whole set of things repeat. So numbers like 3.6734673467334 ... So in my head, I'm looking, okay, that doesn't really repeat, but it does because 6734 is repeated a few times. So this is a repeating decimal. Okay? Or even numbers like 4.21232323 ... So it's okay if the first couple numbers don't repeat. But as long as the last ones repeat, then it's a repeating decimal. Okay? And again, this all falls under rational numbers. But what makes a real number? A real number is rational plus irrational. So real numbers are rational plus irrational. So you know a really famous irrational number, and we celebrate it on March 14th sometimes. Some people do. What do you think is on March 14th? It's Pi Day. So remember the symbol pi? That's an irrational number because it never terminates and it never ends. So I have to zoom in a little bit because these are a lot of words. So you're going to want to write kind of small for this one because we're going to want examples and written stuff. So if it helps, maybe like draw a line down here. So irrational are non-repeating, so they don't repeat, and non-terminating, decimals. So ones that don't repeat and ones that never end. They're also non-perfect square roots. And we'll get into what that means in a second after I talk about repeating and terminating decimals. Okay, so think about pi. Pi is 3.14159, I think 26 maybe. And it just goes on and on and on, right? It never ends. And the sequence never repeats itself. It's always a new number. Never repeats. So same thing as like 2.45678912367 ... That never repeats itself. And it also never ends. That's what this ... means. It means that it goes on and on and on. Okay? Well, let's make that a 9, so it's not 6, 9. So it doesn't look like it's repeating with that 6, 7 before. All right. Let's talk about what a perfect square root is. So a perfect square root is something that we could do, like what's 2 squared? 2 squared is really 2 times 2. So what is 2 times 2? 2 times 2 is 4. So if we look at just the square root of 4, we would have to figure out what times what gives us 4. What times itself will give us 4, because that's what a square root's asking. We have to multiply the same thing twice because it's a square root. Square means 2. And what will that be? So the square root of 4 equals 2, right? Because we said 2 twice gives us 4. So non-perfect square roots. Non-perfect square roots are things like the square root of 5. Because nothing times itself is going to give me 5. Because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So nothing times itself. No whole number times itself is going to give us 5. So it's not a perfect square root. We could also put a negative number out front, and that's still irrational. Whether it's negative or positive, it doesn't really matter. So we could have made a negative 2 point, right? Because these all build upon negatives, which are integers and all that stuff. So something I'm going to add, so see how we did the square root of 4 equals 2? If we scroll down to natural numbers, is 2 a natural number? Yeah, so we'll have to add perfect squares to this, because the square root of 4 equals 2. So this is a natural number then, because I can count 2 on my fingers. Okay? So let's go back up. Some real numbers are rational, and irrational numbers. Okay, so I know that was a lot to take in, so you're going to want to use this as like a little reference point for when we go to the next page. All right, so we are going to start by listing all classifications of these numbers. So the classifications were natural, whole, integer, rational, irrational, and real. Those are our classifications of numbers. Okay, so -1, where does that fall? Where do negatives start in that chart? Negatives start at integers. So it's an integer. And if it's an integer, what does that mean it's also? An integer means it's a rational number. And if it's rational, that means it's real. Okay. What about the square root of 5? So square roots, is it a perfect square root or a non-perfect square root? Well, 5 is a non-perfect square root. So where do they come in? Non-perfect square roots are irrational. So irrational. And if it's irrational, it means that it's real. What about 0? Where does 0 come in at? Where does 0 come in? 0 starts at a whole number. So it's a whole number. Then if it's a whole number, that means it's a integer. And if it's an integer, that means it's rational. And if it's rational, that means it's real. Last one, it's a decimal. So does this decimal repeat? No. Does this decimal terminate? Does it end? Does it stop? Yes, it's a terminating decimal. Terminating decimals are rational. They're rational, and that means that they're real. Okay, so this, in example 1, we listed all of the classifications. In example 2, they want to check all the boxes that apply. So 3/5 is a fraction. Where do fractions come in at? All fractions are this. All fractions are rational and real. Look at this decimal. Okay, so a decimal. Does this decimal terminate? Does it stop? No, because it's got that bar over top. What does that bar mean? What does that bar mean? Remember? It means that it is a repeating decimal. So repeating decimals are rational, and if they're rational, then they're real. What about 9? What about 9? Can I count 9 on my fingers? Yes. So if it's a natural number, that means it's a whole number. And if it's a whole number, that means it's an integer. If it's an integer, that means it's rational. If it's rational, that means that it's real. All right. So down here, in example 3, we want to know if it's true or false. And if it's false, correct the statement. So I'm going to do the first one with you, and then I'm going to let you do the next couple. If a number is rational, then the number is also an integer. Is that true? Can all rational numbers be integers? No, right? Are fractions integers? No, right? So this is false. This is false. And then they want you to fix it. How do you think this sentence would work? I would think it works if we flip rational and integer. If we put, if a number is an integer, then the number is also a rational number. Right? Would that make it true? Yes, right? So try the next 3, not next 3, try the next 1, 2, 3, 4, 5, 6. Try the next 6, make sure you're correcting the statement. All right, so pause and try this on your own. All right, so hopefully you used your chart as a helpful guidance there. So if a number is irrational, then it is also real. That's true, right? -12. -12 is an integer, which means it's a rational number. Pi is a real number, right? Pi is irrational, which funnels up to real. 0 is a whole number, so that funnels up to integers. This decimal is not a natural number. decimals don't get introduced until rational or irrational. And since it's a terminating decimal, it's rational. -1/6, we said all fractions are rational numbers. All fractions are rational. Okay, so that ends it.